the general public, especially in the West, begin to realize that bringing aging under medical control is coming, and may be coming in time for them. That we will go from a point where hardly anybody thinks they're going to live to even 150, to a point where most people think they're going to live to 1,000.
Le podcast
Humain demain.
Salut à tous chers abonnés, on se retrouve pour un nouvel épisode de la série de podcasts Humain demain en collaboration avec l'AFT, l'Association française transhumaniste. À travers cette série, notre but est d'explorer l'avenir technologique de l'humain. Pour chaque épisode, je vais recevoir des chercheurs, scientifiques, philosophes, politiciens ou encore artistes, ainsi qu'un membre de l'AFT ou un de leurs collaborateurs en tant que co-animateur. Comme pour l'épisode avec David Pierce, cet épisode sera en anglais et nous recevons un invité de taille, Aubrey de Grey. Biogérontologue britannique est mondialement connu pour son travail sur les causes du vieillissement et l'extension de la durée de vie. C'est sans doute la personne qui a fait le plus avancer la discipline, faisant passer l'idée de stopper le vieillissement comme une utopie fantaisiste de science-fiction, voire magique, à un champ d'études scientifiques faisant des progrès remarquables chaque année. La conversation sera entièrement sous-titrée, par contre ce n'est possible que sur YouTube, donc si vous écoutez la version audio depuis une application de podcast et que vous ne comprenez pas l'anglais, je vous invite à passer sur la version YouTube de l'épisode. Didier Cornel, vice-président de l'AFT et cofondateur de Quels, va m'accompagner en tant que co-animateur. Salut Didier.
Aubrey de Grey est probablement le scientifique le plus connu au monde pour ce qui concerne les questions relatives au vieillissement humain. C'est aussi une des personnes qui est le plus intervenue dans les médias à ce sujet. Il est né à Londres en 1963, a vécu au Royaume-Uni et particulièrement à Cambridge jusqu'au tournant du XXIe siècle, et puis a vécu alternativement aux États-Unis et en Royaume-Uni, et maintenant vit en Californie. Depuis 2010, il est installé. Aubrey est l'auteur du projet SENSE, SENSE pour Strategies for Engineerable Negligible Senescence, la stratégie pour rendre négligeables les mécanismes de sénescence. Il considère qu'il y a 7 causes principales du vieillissement chez les mammifères et donc particulièrement chez les humains, et que nous pouvons veiller, nous pouvons nous organiser pour que ces causes de vieillissement soient arrêtées, ou plus exactement deviennent négligeables.
Et tout de suite, place au podcast, c'est parti. So thank you, Aubrey. I'm very pleased to have the opportunity to be speaking with you. It's kind of an honor. I'm a big fan of your work. I'm going to ask you the first question. It's a kind of a surprising question because not all people are on board with the idea of living longer, healthy lives. You know, it's a bit of a surprise, but it is what it is. So when you talk to a skeptic who might ask, why do we want to cure aging and live longer? What are the arguments you use to lay out your position?
I really only have one major argument that I use with everybody like that. I simply emphasize and get people to focus on the fact that lifespan is a side effect of health span. If you are healthy, you probably will wake up tomorrow morning. If you are sick, maybe you will not wake up tomorrow morning. So it has nothing to do with how long ago you were born. It has to do only with the relationship between health and being alive. Most people are comfortable with the fact that being healthy is better than being sick. And most people are also comfortable with the idea that we should not be ageist. We should not discriminate against people who were born a long time ago. So really, all I do here is that I help people to separate the question of what is desirable from the question of what is possible or potentially possible. I get people to remember that the only real reason they are so inclined to be ageist about this particular thing is in order to put the impossibility out of their minds. And if the impossibility is going away, if we are figuring out how to make this possible when it used to be impossible, then that no longer makes any sense.
We will speak about non-scientific aspects later, but in the scientific field, what has been for you the most difficult part in longevity research in all these years, or maybe now and in the past?
let me focus on the end of your question, because the answer to the question has definitely changed over the years. At the beginning, when I started thinking about damage repair as a feasible way to bring aging under medical control, it was very difficult to persuade my scientific colleagues that what I was saying made sense. It's quite hard to understand that now, because it's now a mainstream idea. But back then, there was a very deep-seated belief that aging was just too complicated to deal with in a piecemeal manner, in a divide and conquer manner. In other words, when people heard me talk about repairing the molecular and cellular damage of aging, they could not really see the difference between that and trying to address each of the pathologies of aging individually, which they already knew was never going to work. There are too many of them, and they are just, too hard to deal with. It took me a long time to get people to understand that those two things are not the same, that if you are repairing the lifelong accumulating damage of aging, you have a chance. Whereas if the goal is to stave off the diseases of aging, the pathologies of aging, then it's a losing battle, because those pathologies are progressive. They're going to get more and more problematic as time goes on. So that was then. Now, that battle has been won. It is now, certainly for the past 10 years, it has been acknowledged as a very reasonable thing that we might repair various parts of aging. Some people are, in fact, most people are more pessimistic than me about how soon we will get there. To be able to repair various things, but they're not much more pessimistic. They understand that this is something really worth trying to do, and that we will probably get there eventually. The main difficulty right now, therefore, is the thing that I have been calling longevity escape velocity. So here we are talking about the idea of progressively improving these therapies over time, after the point where we get them to be good enough to give us maybe 20 years of extra healthy life. Thereafter, we will have to make them better and better in order to get more life. And I believe very strongly that it is almost certain that we will successfully improve them fast enough to be able to keep treating the same people and keeping them healthy, even though the problem of keeping them healthy is becoming progressively harder as they get chronologically older. This is something which is too abstract for most biologists. If they can't see how something will happen in relatively concrete terms, they are reluctant to believe that it could happen. And so that's still a difficulty, a difference between me and most of the mainstream community. But it's a very different difference than the one that existed 15 years ago.
So, and you mentioned your theory called the damage repair. Can you explain a little bit more what it means?
Let me start by explaining what aging is. And my definition of aging revolves around this concept of damage. Now, I want to emphasize, first of all, that this definition of aging is not controversial, and it really never has been controversial. It sounds different from some other people's definitions of aging. That's just a matter of taste, really. People would not have ever disagreed with this definition. So the definition is that aging is the lifelong accumulation of self-inflicted changes to the molecular and cellular structure of the body that eventually make the body work less well. That's all it is. So the reason why it's appropriate to call those changes damage is because of the end of the definition. When there's too much of it, the body doesn't work so well. That's the pathologies of late life. Before the damage is abundant, when there's only a little bit of it, the body just gets on with what it's doing. It doesn't get in the way. Very much in the same way that if a car has a little bit of rust, it still works perfectly well. It's only when it has a lot of rust that the doors fall off, right? So the damage repair approach simply says, let's do preventative maintenance. In the same way that you can periodically remove the rust from a car so that there is never enough rust for the doors to fall off. Similarly, you can do the same thing for all of the various changes that happen in the body as a side effects of the body's normal operation. That's what I mean when I say self-inflicted. The question then is this practical? Is it feasible? And of course, what I did 20 odd years ago now is I enumerated a bunch of categories of damage, types of damage, and I described ways in which we might actually do this preventative maintenance, this repair of the damage.
Let's go to one of these questions where longevists are almost, I would say, fighting. Do you consider aging as a disease or not?
So actually, I don't think that researchers in the biology of aging have been fighting about this, not for many, many years. Of course, only a small minority of researchers actually do much public speaking to the general public. Most of them just hide away and they only talk to each other, right? But the ones who talk to the general public, they have to say things that the public will understand. And some of us have different, styles of doing that. But we all know perfectly well that the question of whether aging is a disease is not a scientific question. It's just a question of terminology. We know that aging is bad for you, so it's definitely a medical condition. But if you call it a disease, then you have all this baggage, all of these connotations of the word that come along. So, it implies, for example, that it's like an infection that could be cured. You could do a single treatment and you would never have aging again until you were reinfected in some way, which of course is nonsense. So we should not call aging a disease. But on the other hand, we should also not call aging not a disease, because if we do that, then people will think that it is not, even in principle, amenable to medical intervention. It may be like the weather, it's inevitable and universal and natural, and let's just live with it, which is, of course, a funny way of saying something that kills you. So I have avoided this for a long time. I say aging is a medical condition, and I do not say whether or not aging is a disease. And I am pleased to say that some of my colleagues who are also who also do a lot of public speaking are picking up on that. They are beginning to use the same language that I've been using for a long time. I think that's progress.
Speaking of progress, since you started this journey against aging, what progress has been made scientifically and technically, but also in regards to the public opinion and also funding and all those things?
Whoa, well, how long do you have? There's been, of course, masses and masses of progress scientifically. Much of the really important progress has been relevant to the whole of biomedical research, not only to aging. Things like the development of induced pluripotent stem cells, the development of CRISPR. Some of it's been specific to aging, the development of drugs that can kill senescent cells, for example. It's very important. A lot of it is still very early stage. The progress, a huge amount of progress still needs to be made. We're nowhere near the clinic. It's still doing experiments in laboratories, but still, it's night and day different from how it was 10, 15 years ago. And of course, Sense Research Foundation has done a lot of that work. So scientifically, I'm very happy about how things have been going, especially in the past 10 years. The previous 10 years, we were slowed down a lot by lack of money, and that's much less of a problem now. All right, so that's scientifically. Then in terms of public opinion, I think there has also been a big shift, long way to go again, but still the conversation, what you read in the general audience media, for example, about the idea that aging might be brought under medical control, that whole conversation is much more respectful than it used to be. It used to be kind of entertainment. And that's changed a lot. In terms of money, again, huge changes. Really, two big changes have happened that I can identify. The first one started about 5 or 6 years ago when investors started to get involved. So I mean here specifically people who want to make money by giving money rather than just philanthropists who give the money away. That made a huge difference because investors generally write bigger checks than donors do. So a lot of projects got accelerated as a result. And at Sense Research Foundation, we're a non-profit, but we developed a business model very quickly where we would spin projects out as startup companies in order to capitalize on this investment sentiment. And I spent a lot of my time speaking with investors, even though I myself do not think about money at all. The other big development happened only last year. Last year was a huge year for philanthropic support for aging. And the main reason it was because several really wealthy crypto blockchain people came along and started putting real money in. For example, someone gave $70 million to the Buck Institute. Several examples like that. The main way in which we at Sense Research Foundation benefited was because of a big hitter named Richard Hart. He didn't actually write us a big check. Instead, he got his many followers to write us checks. And that's good enough for me. So we are in a very different position now than we were a year ago. And I could go on. There are lots more. Of course, there's still some progress being made in this way. So, for example, last year, Jeff Bezos got seriously involved, putting billions of dollars into this new company called Altos. That was a long time coming. The first time I spoke to Bezos about aging was 16 years ago. But here we are.
About this, I sometimes say, that indeed, like you say, we have now a few big companies investing for longevity, but sadly there is not even one public institution who has as an official goal to fight against diseases related to old age. There are public institutions studying diseases related to old age, but not fighting against them. How did you ever try, and what do you think are the avenues to convince public institutions? I would say especially in your native country, so UK, and especially in the country where you now live and work, the US and California.
Public institutions always have one priority, which is the decisions are made by elected representatives, and their one priority is to get re-elected. So they are always trying to follow public opinion. They are very reluctant to try to lead public opinion and change public opinion because they feel that it will go against them. And that's why they're always at the back of the chain, back of the queue in terms of actually doing anything that they used not to do. But now even that is beginning to change. There are people in government in the US and in the UK who are very interested in trying to change public policy to be more translational, more interventionist in relation to the biology of aging. And these include quite senior and influential politicians. For example, in the US, a particularly prominent guy that's involved in this way is Newt Gingrich. He was, I think, chair of the House of Representatives or something like that, something very senior, quite a long time ago. He's been interested in regenerative medicine and aging for a while, and he's now become very vocal. He is using his influence to get other people involved. So we may be quite close to a real tipping point in public policy in the US in this regard. And certainly a number of people who really know the field well are putting a lot of effort into trying to make that happen. In the UK, a little bit less optimistic. I believe that even though there are people who are doing exactly this same work, trying to change public policy, that it's more of an uphill battle in the UK, just because people are more conservative.
If I may say, go a little bit further. So you said the problem of public institutions is that they are elected people, but there is at least one big country with new technologies where they have less this problem is China. But there is, China is, of course, we know less about this, of course, but as far as I know, it is the same situation. But maybe you know a little bit more about this?
I don't know as much as I would like to know about thinking at the top of government in China about this. I have heard only very occasional statements by people who may be speaking for the government in this regard. And I have a fear that in China, they don't listen to the West very much. They probably don't have as much of a sense as they could of how much progress has already been made in moving towards controlling aging. I'm certain they do understand how big of a problem aging is for them, same as it is in the West, in terms of the proportion of the population who are sick because of being old. But whether they really understand that medicine is moving towards a solution and that they could help, I'm not so sure.
So back to science and technology in the longevity research. So a lot of technologies follow some sort of exponential growth, especially information-based technology like Moore's law for computing. Do you see such a growth in longevity research? Do you expect there is an exponential growth?
Yes, but in a different way. And it's quite important to understand this in detail. So I actually took the trouble to write a whole editorial about it several years ago, which was comparing the singularity with the Methuselarity, as somebody called it, namely the point at which we reach longevity escape velocity. So the difference is that in order to maintain longevity escape velocity, you need to continue making progress, making therapies better and better. But the rate at which you need to do that, the minimum rate, actually slows down as time goes on. It doesn't speed it up. So that means that the difficulty of maintaining longevity escape velocity is very different from the difficulty of maintaining Moore's law. And very, very much easier. And that's important to keep in mind. It really underpins why I am so sure that when we get to longevity escape velocity, we will stay there.
If I may add something, somebody spoke concerning the, let's say, research field. It was ironically, he spoke about Moore's law, Moore's law in the other way, because, and we are coming back to public institutions and more legal rules in the US, and even more, more or less, sometimes even more, sometimes less. In Europe, you have this incredibly complicated legislation, especially for clinical tests. In Europe, we have the GDPR. In California, you have kind of the same. Let's say, what is for you 1 or 2 points that you would change, that it's something realistic that could be changed if you were, let's say, in power?
Yeah, it's a difficult question because, it depends a lot on society's view of risk versus benefit. And, society is entitled to have a view. I do not want to tell different societies how to think necessarily. Therefore, I think the main thing for me is the fact that different societies around the world have different views. So you mentioned how China, they don't have to worry about getting elected. But of course, also different countries have different levels of concern about about safety in experimental medicines, for example. And therefore, I think the main way in which we will see progress being made is by virtue of that variation, that spectrum we've got also, of course, individuals self-administering, self-testing, doing experiments on themselves and doing it in a clever, informed way so that we actually get information out of it. Perhaps not such high quality information as we get from a regular clinical trial, but still lots of information. And so, I don't think we need to worry too much about this Eroom's law thing, about things slowing down. The science is continuing to move forward at an accelerating rate. And as that happens, the medicine will move forward as well at a similar rate, I think.
What are the big milestones we already achieved, in your opinion, and which one remains?
It's really hard to point to actual milestones. I've always used longevity, escape velocity as the big milestone in the future. And historically, I've also spoken about the kind of the mouse equivalent of that, getting to some particular amount of increase in longevity in mice. And we're getting pretty close to that now, I think. But perhaps the biggest milestone that we need to be thinking about right now is one that I only started to talk about maybe 5 or 10 years ago. And that is the point at which the general public, especially in the West, begin to realize that bringing aging under medical control is coming, and maybe coming in time for them. This is something which will change everything, because if you think about the influence that how long you think you're going to live has over how you spend your money, it's huge, right? It determines things like what pension plan you want and what life insurance and health insurance and inheritance arrangements and so on. So when that changes, it's going to be a very big change. And I'm pretty sure that when it changes, it will change very, very suddenly. That we will go from a point where hardly anybody thinks they're going to live to even 150 to a point where most people think they're going to live to 1,000. And that will happen overnight almost, like over a period of a few months. Why do I think it's going to happen so suddenly? Basically because of people like me who are out there determining public opinion. There are only a few experts in this field, maybe only half a dozen of us, who are really, we take the trouble to speak to the general public a lot. And, I'm out there saying one thing right now, and the rest of them are not saying the same thing yet. They're saying more cautious things. But that will change as a result of just a few more small breakthroughs in the laboratory. Certainly, if we start to get mice living a year or a year and a half longer than they currently do, as a result of therapies that are given to those mice when they are already in middle age, I believe that will be enough to get people like David Sinclair and Brian Kennedy and so on to be out there saying pretty much, yes, Aubrey was right all along. And when that happens, it's going to be, Oprah's going to start saying it. I don't know who the French equivalent of Oprah is, but you get the idea. And that's going to change everything very quickly. So I keep telling people that they need to anticipate that.
Just not the French equivalent of you, but the two, let's say, best known people on the French side are probably Jean-Marc Lemaitre. And Jean-Marc Lemaitre is one of the best scientists concerning cellular rejuvenation. He made rejuvenation of cells of centenarians already quite a few years ago. Yep. And the other person is Miroslav Radman. He's from a French guy, but living now in Split, Croatia. And both are kind of radical longevists. And Jean-Marc Lemaitre wrote very recently, just a few weeks ago, a book. And the title is Guérir de la vieillesse, so cure senescence, cure aging. You were speaking about when we will have mice living longer than the maximal lifespan, the things will change. But the problem is at the moment we don't have mice living longer than the maximal lifespan and it's not progressing since long. And for me, this is one of the sad mysteries of aging. So we progress concerning the average lifespan, but we don't progress concerning the maximal lifespan. Well, in a few days, the oldest person in the world will be the second. It's really in a few days, but the second is not the first. Jeanne Calment lived longer. She died 25 years ago. Well, I know that there are some people saying, it's not true, but anyway, we don't progress. Why is the difference between progress of average lifespan and absence of progress of my maximal lifespan so spectacular? And after that, I will have a question about mice more specifically, and let's say a test about mice, but I will maybe listen to your question first, to your answer, sorry.
So let me answer the question about average versus maximum in two parts, one for humans and one for mice. So in the case of humans, I don't think we really know the answer, but what we can say is that there are only a couple of people who died 25 or so years ago who are paradoxical. So the so of course, Jeanne Calment died in 1997. Sarah Naus, the runner-up, the person who will be overtaken tomorrow, died in 1999. The person in the number 3 position was established fairly recently to be not true, that she was actually 20 years younger than she was thought to have been. So now there is only one other person from that generation who lived exceptionally long, to 117. This was a Canadian woman. So with the exception of these 3 people, we have actually seen a pretty smooth increase in maximum lifespan at almost the same rate as the average lifespan. The average lifespan in the West has been going up by maybe 2 years in each decade, and the maximum lifespan has been going up by maybe 1 year in each decade. So if you ignore just these 3 people. So those 3 people are definitely strange. They are definitely paradoxical, but still, it's important to see that by and large, we are still seeing progress. Now, in mice, we have a very different story. In mice, even if we look not only at one mouse, but actually at the experiments that have been done, and we look at the normal scientific definition of maximum lifespan, which is the average lifespan of the longest living 10% in the experiment, the longest living 10% of the mice, then yeah, we have seen basically no increase for 20 years at least. And we must ask, why is that? I believe it's very simple, that the way we're going to do this is by damage repair, rejuvenation, rather than by what I like to call messing with metabolism. In other words, giving drugs that, like, for example, calorie restriction mimetics. I believe that can only go so far, and it's no surprise to me that we are already doing as well as we can by that approach. But damage repair does not have any limits to it. So the difficulty is, of course, that in order for damage repair to work, it needs to be comprehensive. You need to repair all of the types of damage reasonably well. And at the moment, some of those are still beyond us. So that doesn't give me any reason to be pessimistic about the fairly soon the progress that we will make in maximum lifespan of mice.
Right. You mentioned that some drugs are not very effective, or at least they won't really radically change our maximum lifespan. Is it the NAD boosters, resveratrol, metformin, this kind of thing?
Those kinds of things, yes. And also rapamycin and the analogs of rapamycin. All of these things are drugs that in one way or another, they kind of trick the body into thinking that it is in a famine, that it's not getting enough calories, even when it actually is. And that is very useful if you're a mouse, because animals have a system for responding to famine that allows them to maximize their ability to have offspring and pass on their genetic material. And that's great if you're a mouse. Problem is that it doesn't work nearly so well for long-lived species like human beings. And we understand why it doesn't work so well. However, that doesn't mean that these medicines are useless, not at all, because they do have good effects on health in general, especially on health earlier on in life. So they can extend average healthy lifespan, a significant amount, probably, even if they cannot extend maximum lifespan very much.
Since we are speaking about, let's say, the therapies who are the most followed at the moment, can you say a few words first about senolytics and a few words about therapies related to blood?
So let us start first with senolytics. So senolytics are drugs that selectively kill what are called senescent cells. So first of all, what is a senescent cell? It is a cell that has got into a bad state where it is not working properly. Maybe it's doing some of the things it's supposed to do, but it's also secreting proteins and other molecules that are bad for the neighboring cells. That's called the senescence-associated secretory phenotype. And that's the reason why, even though we do not have very many senescent cells in the body, even in old age, nevertheless, they can do a lot of harm. So it would be great if we could kill them. And this was one of the things that I suggested 20 odd years ago when I first started talking about damage repair. It's one of the main categories of damage repair. A big and very surprising discovery from about 10 years ago was that we could kill these things genetically, by making engineered mice, and that the benefits were very broad, more broad than I would have expected. And then not long after that, people made another big discovery, which is that there are small molecules, drugs, and even natural products that you can have in the diet of mice, and they will help to kill off these cells without killing too many other cells that you don't want to kill. And sure enough, this seemed to be good for the mice. So senolytics are really a great example of damage repair that is now pretty close to working for humans. There have already been some clinical trials which have gone, some of them have gone okay. So this is one of the most exciting areas. Then you were asking about blood. Now, so of course, here what you're asking about is whether it may be beneficial to replace some of the blood of an older person with the blood of a younger person. Typically, what we try to do here is not actually replace the whole of the blood, but just the plasma. In other words, we don't try to replace the cells. And certainly in the laboratory, in mice and rats, this seems to be beneficial in a lot of different ways. Now, of course, people are very interested in understanding why it's beneficial, what molecules are present at higher amounts in old blood and are bad for you, or what molecules are present in higher amounts in young blood and are good for you. It could be either or both, of course. But in the meantime, while we still don't really know the answer to that question, people are experimenting with doing this, and in various different ways. And, it's very early stage. We cannot say anything really about whether this is beneficial in humans, but it could be. The only thing I want to say about it as a note of caution is that we have to remember that the blood is simply a highway. It's a way of it takes things from one cell to another around the body. And therefore, everything that's in the blood was put there by cells, right? So if bad things are being put into the blood, then we can fix it by fixing the cells that are putting those bad things in. And similarly, if good things are not being put in as much as they used to be in young people, we can fix that by fixing the cells that should be putting more in, and so on. So that's my preferred approach, but as a kind of temporary stopgap, as a way to get some of the same effects more easily and more quickly, plasma exchange, as it's called, may very well be very promising.
Maybe one kind of technical question. There is something in my perception that it's going in the research that is going less good than before. Before, when people were testing things, they were testing how long do the mice live if we have this new therapy. And now for the senolytics, but also for the blood products, and also for other experiments, very often, so they test something, the scientists test something, and then they kill the mice to see what's if the products were efficient, but they don't even keep a few mice to see if they are living longer. And for me, that's kind of crazy. So you are studying things to see if, at the end of the day, if people can live longer, but in an intermediary stage, if mice can live longer, and you don't wait to be sure that it's really working.
It's not really much of a change, actually. It just may be more conspicuous now. It's always been a problem. The thing is that when compared to a lot of other types of experiments on mouse longevity are very expensive. It just takes a lot of money to keep mice alive, even however healthy they are. And so this has always been a problem. But you're quite right, it still is a problem. In fact, perhaps it's an even bigger problem now because we have more promising interventions. So people would, and the scientists know this, scientists would love to do their longevity experiment, but it costs too much money. But now that's changed because there's a lot more money in the field. And in particular, a lot of that money is targeted towards testing interventions. So, for example, one of the big things that we're going to do with the money we received last summer, this very big windfall, is we're going to start doing many more longevity experiments on mice than we would otherwise have been able to do. Another example is at the Buck Institute. They received a huge grant last year. I think it was $70 million. And that is entirely going to be spent on mouse lifespan experiments. So, it's getting better.
And there's also the field of regenerative medicine, cell reprogramming, rejuvenation. So I think Yamanaka won a Nobel Prize, so it's quite a big deal. And there's also David Sinclair's and others. Are you excited by this approach? Do you think it's the most likely path?
I'm excited by it. And it certainly is a very important research area. But in its current state, I think we have a long way to go to make it safe. The idea, the de-differentiation and rejuvenation of cells using these Yamanaka factors works really well in cell culture, in a petri dish. But the thing is, in a petri dish, you are looking at the average of the cells. Basically, the cells that you care about are the bulk of the cells, the majority of them. Whereas if you try to do the same thing in the body, then you are influencing a lot of different types of cell that are not just different in terms of what they do, like, muscle cells versus brain cells or whatever, but also in terms of the damage that they have in them. And I'm very worried that this partial reprogramming approach will tip a lot of cells that are in a kind of pre-cancerous state. They have a lot of mutations, but not enough of those mutations to make them cancerous. Will push some of those cells over the edge into being actually cancerous. Now, of course, this is a fairly obvious concern, and people working in partial reprogramming have tried to evaluate it. But the thing is, if you are doing your experiments in mice, you can't really ask the question because they just don't live long enough. Even if you are making a lot of cells cancerous, the mice will already be dead by the time the cancers get big enough to be detectable. Whereas if you do this to humans, let's say to humans age 60 or 70, and your goal is to make them live to 100 instead of 90, then, by that time, that is long enough for cells that became cancerous as a result of the treatment to actually kill the person. So I'm worried. I think there are two possibilities, though. One is that we will find different methods to de-differentiate cells in the body, different factors that can take cells back into a younger state without having the ability to damage them properly and make them into cancers. Now, exactly what those factors would be, it remains to be seen. But a company that I used to work with, Ajax Therapeutics, has some ideas there. And I'm hoping that now that there are several companies working in this space, a lot of other ideas will also be explored soon. The other possibility, of course, is that we may make really big progress against cancer. It's fine to create a lot of new cancers if you can genuinely get rid of them before they become problematic. And we're getting closer to that as well. There is now really good progress on controlling cancers when they make this enzyme telomerase, which 90% of cancers do. And there's also great progress being made in many ways in activating the immune system against cancers, which is something that people were trying to do for decades. And then suddenly, just 8 or 10 years ago, some breakthroughs were made, and now it's looking really good.
No, maybe since we are speaking about 50 minutes already, a few personal questions, about you and also the last events. The first is, so you are the most well-known person in the world for longevity. What decided you to be active in this field? Some people say it is because you married a much older woman when you were young, but it's not the only reason, I suppose, and maybe it's not even a reason.
Yeah, that wasn't a reason at all. The reason was, though, that I learned from my wife, my ex-wife, how little was being done by biologists to work against aging. I had always known, throughout my whole life, that aging was definitely the biggest problem for humanity, and that it could, in theory, be solved. But I had always assumed that everybody else agreed with that, and therefore that biologists would be working as hard as they could to bring aging under medical control. And it was only by talking to my wife and to other biologists that I was meeting that I realized that that was not true. By that time, I had already done quite well in my original research area, which was artificial intelligence. And so I knew that I had the ability to work on hard problems. And I also knew that people who switch fields often make big breakthroughs in their new field because they think in a different way from the people who have been in that field for all their lives. So I thought I must try. And of course, it worked out. That's really the only reason why I did this.
And now let's come to the let's say last news concerning the Me Too affair that exploded in 2021. So now, I don't know, 8 months ago or something, you were accused by a well-known and competent young female scientist, Laura Demink, and by another woman also working in the field to be a sexual predator, almost from one day to another day, and literally from 1 month to another month. You switch position from top scientist of the field to presumed sexual aggressor. Now the board of sense, after many many episodes officially declare that you are not a sexual aggressor, but you were, let's say, fired again for some other reason. So, what is the last news that you have to give at the time that we are recording this in beginning April?
Well, I can't say all that much because there is plenty still going on. But I can say that the main focus right now is that a large number of people who have given money to the foundation are very upset that I was removed from my position. And they are trying to fix that. The main concern is that the board of directors of the foundation have a legal duty to do what the donors want, to respect donor intent.
I interrupt you just to say that in the notes of this meeting, you will find information about people who are doing this and information about the donors. And
essentially, the donors are putting pressure on the board to reverse what they have done, to restore me to the foundation, and to allow me to control how the foundation spends donors' money, because that is why the donors gave the money in the first place. And the board are resisting that at the moment, but maybe not for long.
So now I'd like to know if we do some anticipation, because I think it's important sometimes to try to imagine what could happen in society if we get rid of aging, or if we manage it effectively. So do you anticipate profound changes? I don't know if you think about it a little bit or no?
I don't think about it all that much because, I don't think it makes any sense to think about the distant future. Even 20 years, 30 years in the future, let alone 100 years. So many things are likely to happen that we cannot yet even imagine. So really, I just think about things that we do know. We can be very sure that nobody is ever going to want to be sick. They're always going to prefer to be healthy. So that means that as these therapies become developed, they will become universally available very quickly. I think it will be extremely quick simply because these therapies will be economically profitable to countries. They will pay for themselves by keeping people from being expensive when they are sick. But beyond that, it's hard to know really how society will change. There are so many other things like the rise of automation and changes to energy utilization, moving to renewable energy and so on, things that are happening at the same time in parallel with the development of anti-aging therapies. And how it all plays out, it's possible for me to say.
Yeah, no, it makes sense. Predicting the future is not a very easy thing to do. So what will be the most effective way to accelerate research today? More money, more billionaires interested in longevity?
So until last year, I would have said that still the number one thing that is needed is more money, especially more money applied to the very early stages, the pre-investable technologies that non-profit organizations like Sense Research Foundation are doing. But now that problem has mostly gone away as a result of the huge amounts of money that came in last year. So now I believe that the number one problem is talent, people. There are still not enough people, especially not enough young scientists, who want to get involved in this particular field and to help to make a difference. We have had job openings available for months and months that we just are not getting good applicants for. And, it's not that we don't pay enough salaries, it's true in the private sector as well, in the startup companies. So, we need to get the word out that aging is the thing to have your career in.
Longevity is considered as something important for people who call themselves transhumanists. You know about transhumanism. Do you have also interest concerning other fields of, let's say, human augmentation, human enhancement, like reducing suffering, the idea of David Pearce, or like improving intelligence? Or other things?
So I wouldn't go so far as to say I agree with David Pearce. I gather that the name for his way of thinking is negative utilitarian, by which he means basically, suffering is so much more important than fulfillment and positive things that we should just get rid of suffering completely by whatever means, by mesmerizing people or whatever. I don't really agree with that. But more generally, I'm certainly very enthusiastic about all of the other pioneering areas of technology, artificial intelligence and nanotechnology and so on, that transhumanists have been interested in for a long time. I'm not too sure about the word transhumanist. I think it may scare people too much, but certainly the technologies that come under that umbrella are very much things that I'm interested in and that I support.
Yeah, and maybe to go further in this question, there are many transhumanists are also following all questions related to existential risks. So the existential risk for all of us, well, that's more than a risk. That's at the moment something certain is our personal death. But the risk of humanity disappearing is also something very important and that many transhumanists are following. Do you follow that especially? Or do you...
A little bit. So I'm not so sure that almost everybody dying is any worse than absolutely everybody dying. I think that, that's an open question, really. But I'm not in favor of either of them. So, I don't want to have an asteroid hitting the Earth, even if a few people would survive, like by virtue of being in a spaceship or something like that. So let's look for asteroids a bit more carefully than we are so far. Things like that.
And so we're reaching the end of our conversation. I'd like to know how can someone contribute to the field on a personal level if one of our listeners is convinced by this battle against aging?
Well, of course, the answer to that question is very different depending on the person who is asking the question. If you are a billionaire, then you can write a check. If you are a scientist, you can work in a useful, relevant field that will hasten the defeat of aging. If you are a journalist, you can interview me, just the way you're doing right now. But everybody can do advocacy one way or another. Depending on who you know, people who are wealthier than you, people who have political influence, people who have any kind of influence. And everybody can do it, talking to their friends, their family, their colleagues, just getting people to understand more about how the world will change and how soon it may change as we bring aging under control.
The last question, well, more precisely, the last two questions is, what is the best place online to know more about you and about the field of longevity? You can say a few websites,
sure.
And we will add. And the very last question is, did we forget something that you want to approach?
Okay, no, I don't think you forgot anything. I think we covered a large number of things. I would say that there are now quite a few resources out there that work well for this field. There are a couple of groups that are really focused on educating the general public about news in aging. So lifespan.io is one of them. Another one is First Longevity, run by Phil Newman in the UK. And there are others, of course. There is a much more long-standing one, Fight Aging, which is a blog run by Reason. So, those are the kinds of places to go to keep informed. There are, of course, also communities, such as, for example, if you're an investor, there's the Longevity Investor Network, which is now part of lifespan.io. There's plenty of places to go. There's the Foresight Institute, which have a strong interest in all futurist technologies, but especially in health extension, life extension. And, I'm a very big supporter of what they're doing. So there's quite a lot of choice out there now.
Thank you again for your time. It was very, very great to talk to you and to have a deep dive into
Thank you for having me on the show. Thank you for having me. It's been great fun.
Merci à vous tous d'avoir suivi ce podcast jusqu'au bout. Je vous invite à vous abonner, à regarder les autres contenus que nous produisons sur la chaîne YouTube. Si vous voulez aller plus loin, nous avons mis des liens dans la description. On se retrouve pour un prochain épisode. À bientôt.